Example 10. 2 moles of an ideal monoatomic gas. 2 moles. So N equals to 2. An ideal monoatomic gas. So monoatomic gas, the degree of freedom, number of degree of freedom is 3. In a closed container at constant volume. Constant volume is heated until its pressure is double. If the final temperature of the gas is 750 K, calculate the initial temperature of the gas. So we need to calculate T1. And we know the final pressure is twice, double of the initial pressure. So this and the temperature given, the final temperature given is 750 Kelvin. So this is all the information that we have. So how can we look for the initial temperature? So constant volume, what law is this? POV. So this is constant and this is the law. So it is pressure law. So pressure law is P1 over T1 equals to P2 over T2. Now we do not know our P1 and we are looking for T1, but we know our final pressure. Our final pressure is twice of the initial pressure and the final temperature is 750. So pressure 1, initial pressure, we can cut because left and right is the same thing, it's a mathematics. So you will get 750 equals to 2T1. So your initial temperature is 375 Kelvin. Okay, now the next question, the question asks us to look for the change of the internal energy. So it means final internal energy minus initial internal energy. So how are we going to solve this question? So we need to look for the initial internal energy using formula F over 2 and RT1. So we know the degree of freedom from monoatomic gas is 3. So 3 over 2 and the number of mole is 2 and R is 8.31 and temperature 1 is 375. So you will get your initial internal energy 9348.75 joule. Okay, now let's look for final internal energy. So final internal energy is F over 2 and RT2. So our degree of freedom is 3, our number of mole is 2, R is 8.31 and final temperature is 750. So our final internal energy is 18697.5 joule. So we are looking for the change in internal energy, means final internal energy, which is 18697.5 minus initial internal energy, which is 9348.75 joule. So you will get 9348.75 joule. So this is the answer.